Hello, in this lesson, I want you to evaluate and analyze and graph exponential functions. I want you to solve problems involving exponential growth and decay. Some vocabulary we're going to come across is algebraic function, transcendental function, exponential function, natural base, continuous compound interest. Everything we're going to do is an example of an algebraic function, something that can be written as a rule. A transcendental function, it occurs because you can't express this in terms of a algebraic function. So in other words, it transcends algebra. Transcendental function or algebraic function comes from adding, subtracting, multiplying, or dividing constants. If you have something beyond that, then it's a transcendental function. Here we have an example of an exponential function. An exponential function is going to be a number times another number raised to a power. That power is your variable. That's what we call it an exponential function because the variable is in the exponent. If a was 0, you won't have anything, so a can't be 0, and we're going to say b has to be positive. So anything like that. So an example, 4 to the x, 1/3 to the x, 7 to the negative x. You can have a negative exponent. An example, if 2x to the negative 3, because the exponent isn't a variable. 5 to the pi, because it's not a variable. 1 to the x, because if b is 1, it's never going to change because anything to the 1 power is 1. So b can't be 1 when we do this. When we take a look at our first problem here, we want to sketch and analyze this graph, and I think the easiest way to sketch a graph is make a table. If you don't know anything else, when you come to something new, we can always make a table. So I'm going to go like -2, -1, 0, whoops. Let's write them in the order I said, not the order I wrote down. -2, -1, 0, 1, and 2. Well, anything to the 0 power, because y is 4 to the x, anything to the 0 power is 1. So when 0, you're at 1. 4 to the first power, well, that's 4. 4 squared, that's 16. It gets really big fast, doesn't it? That's the one thing about an exponential function. 4 to the -1, well, that'd be 1/4. 4 to the -2 would be 1/16. So in other words, we know it crosses at 1, and it goes up really quick. It never crosses the x-axis because an exponent doesn't make it negative. So that's the sketch. It'll look something like that. Now let's talk about describing that graph. Well, my domain, notice, my domain can be any number in the world. So we're going to go from -infinity to +infinity. Our range, since it can't cross 0, is going to go from 0 to +infinity. When we talk about the end behavior, the limit as x approaches -infinity, forgot my negative sign there, well, f of x is going to approach 0. And the limit as x approaches +infinity, notice it gets really, really big, f of x is going to approach +infinity. Maybe I should, instead of equal sign, I should say my arrow, because that's what it's approaching. And it's increasing the entire way, isn't it? Because we go from left to right. I just realized I didn't state the intercepts. Well, the y-intercept is 1, because that's where it crosses the y-axis. Notice it never crosses the x-axis, so there is no x-intercept. There we go.